We now discuss the solution of a problem from the section Differential Calculus. The problem is related to the left-hand limit of the given function. This question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is, let bracket t denote the greatest integer less than or equal to t and curly bracket t denote the fractional part of t. The integral value of alpha for which left hand limit of the function f of x is equal to bracket 1 plus x plus, it is a quotient where the numerator is alpha power in the power 2 bracket x plus curly bracket x plus bracket x minus 1 by the denominator 2 times bracket x plus curly bracket x at x is equal to 0 is equal to alpha minus 4 by 3 is, and we are now given a function. This is your function involving bracket x and the curly bracket x. Agreed. And we want to find the integral value of this alpha, what is appearing in this function, for which the left hand limit of this function at x is equal to 0 is given to be alpha minus 4 by 3. Then we have to find the integral value of alpha. Agree? So let's now get into the question. That's your given question. We first get familiarized with the greatest integer function and curly bracket function, right? So these are the two concepts which we require. Let x be any real number, then bracket x be the greatest integer less than or equal to x, and the curly bracket x be the fractional part of x. Then curly bracket x is equal to x minus bracket x. That means from the given real number, subtracting the greatest integer less than or equal to x, then you will get fractional part. And bracket x plus n, where n is any integer, then it will be bracket x plus n. Agreed. So these are the two results which you should know to get into the solution. We now discuss the solution in detail. Bracket of 1 plus x is equal to 1 plus bracket x. We are using bracket of x plus n is equal to bracket x plus n for any integer n. Agreed. Agreed. Then 2 times bracket x plus curly bracket x, we write it as bracket x plus curly bracket x in red, and bracket x plus curly bracket x is x, because curly bracket x is equal to x minus bracket x. So bracket x plus curly bracket x will be the given real number x. Then it will be equal to bracket x plus x. Agreed. Now let's get into the function. So this is your function. For the first one, bracket of 1 plus x, you can write 1 plus bracket x, and 2 times bracket x plus curly bracket x, you have to write bracket x plus x both in the power in the numerator. Agreed? So that will be equal to 1 plus bracket x for this plus alpha in the power 2 times bracket x plus curly bracket x is written as bracket x plus x, and plus bracket x minus 1 as it is. In the numerator, bracket x. In the denominator, bracket x plus x. Agreed. So now let's get into what will the limit, the left hand limit at x is equal to 0 for bracket x. Why we are doing? Because we have to get the left hand limit of this function at x is equal to 0. For that reason, these are the the functions which are inside the function f of x. So we have to find limit x tends to 0 minus, that is the left hand derivative of bracket x is equal to limit h tends to 0, because x is tending to 0 from the left. It is 0 minus h we have written, and as h tends to 0. For x we have written 0 minus h, yes, as h tends to 0. It will be 0 minus h where h is positive, which is very close to 0, then 0 minus h will be less than 0 but greater than minus 1. Then in that case, the greatest integer not exceeding 0 minus h is minus 1. And limit x tends to 0 minus of bracket x plus x is equal to limit of the sum is equal to sum of their limits we have written. Limit x tends to 0 minus of bracket x we have already seen above, minus 1. And limit x tends to 0 minus of x is 0. Why? Because it is same as limit x tends to 0 of x, because x is a continuous function. So it will be 0. And minus 1 plus 0 is minus 1. Agreed. Now we are ready to compute. Limit x tends to 0 minus of f of x is equal to limit x tends to 0 minus of the function. The function is, we have seen here. Now limit of the sum is equal to sum of their limits. Yes, we have written, and it is equal to 1 plus limit x tends to 0 minus of bracket x is minus 1. So it is 1 minus 1. Limit x tends to 0 minus of the quotient is equal to quotient of their limits, and that will be equal to alpha to the power of limit x tends to 0 minus of bracket x plus x is minus 1 plus 0 minus 1 we have written, and bracket x is minus 1 by bracket x plus x in the denominator minus 1 plus 0. Now 1 minus 1 cancels, and this will be equal to alpha to the power of minus 1 minus 2 by minus 1. That is 2 minus 2 by minus 1, 2 minus alpha inverse, that is 1 by alpha. But this is given to be equal to alpha minus 4 by 3. So this is equal to alpha minus 4 by 3. We continue for further simplification of this one in the next slide. This is what we have. Take the LCM here, take the LCM on the right hand side, we have taken, and cross multiply, we have cross multiplied and simplify, we will get a quadratic in alpha, that is 3 alpha square minus 10 alpha plus 3 is equal to 0. Factorization is very easy, we factorize, we get alpha minus 3 into 3 alpha minus 1 is equal to 0, then we get the values of alpha. Alpha is equal to 3 or 1 by 3. What is that we want? We want the integral value of alpha. In this 3 and 1 by 3, the integral value of alpha is 3. Therefore, alpha is equal to 3. That's your answer. And that is the detailed discussion of the solution of the problem related to the left-hand limit of a given function which involves bracket x function and curly bracket x function. Right. And it is this question strongly depends upon the properties of bracket X. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.